Right. So first and foremost, you have to know that your test 2 will be next Tuesday, next Wednesday on 9th of June. The format and the format of test is similar to the first test, that you'll be doing the test online and then have to submit via Putra Blast unless we have a problem on Putra Blast. Okay. Now, what we need to do today is to revise back, and the way that I revise, usually I just share with you the learning objective and point out what is important. But uh, there are additional things that I have to remind you because it was not stress or it was I was not planning to uh, actually teach that, but since the other group has is on doing that, okay, so there is additional. So what you should do at this moment, okay, this is very important. Okay, number one, if if you still do not have the questions for all the tutorial, I have again uploaded this. And before this, I have given this tutorial. I don't know whether all of you know or not. Some of you do notice that I have given the question for all topics in MS Teams. Yeah. But for those of you who miss it and don't know what is happening, okay, the tutorial question for all the topics are, I put it again under Putra Blast. Okay, since test 2 will be covering these two, yeah, bonding and solid gas liquid, okay. So I would highly recommend you to look at the question again, look at the question on bonding in this bonding and solid gas liquid topic in these tutorial questions. Please look again, and then I have supplied the suggested answer. Okay, so when I say it is important, it is important. Please do so. Okay, please have a look. And I will also remind you that in Putra Blast, I have put quite a number of tutorial video. Okay, remember this. Okay, this question was in test 1, Bohr's equation, so it is there. If you do follow the video on tutorial, I'm sure that you can answer the questions. Okay, as well as the experimental video on experiments. Okay, so make sure that you do know that we have all these in Putra Blast. And for today, I told you that we have additional things that I didn't stress on during the lecture. So you have to again download the new one. Okay, so this is the old one. Okay, lecture notes, and this is the updated one. Okay, so please do so at this right now so that we can discuss it after this. Yeah, please download this updated lecture slide, right? And apart from that, okay, test 2, okay, we will have, as I said, the same format, okay, like this, okay. So you must make sure that you have the necessary apps or whatever to convert into a proper PDF file. So during our first test, okay, there are a few who actually have a very poor PDF file. And remember that you have to name the PDF file according to the suggested, okay, uh, instruction, okay. And some just put it test 1, okay. So you have to follow the instruction, okay. right? Okay. And remember that if you wish to revise your bonding, okay, bonding topic, it is all here. The tutorials, the lecture, the video lectures, the videos on lectures, okay, so you can revise back, and then we will look again what are the things that are very important for you to remember. Same goes to solid, liquid, and gas. Okay, so first and foremost we will discuss solid, liquid, and gas. Okay, so I hope that you have downloaded the one that I mentioned just now. Okay, right. Any question on Putra Blast? No. Okay. All right. We will revise on the topic of solid, liquid, and gas. Oh, sorry. Okay. So remember that we have discussed this. Okay. And we also have discussed the tutorial, but we didn't discuss the tutorial that I have given at the early of semester, but I did share some other questions. Okay, but this time you have to look at the tutorial that I have shared at the early of semester in the Putra Blast, and I have provided the answer. And today I'm going to add some more information that I initially don't want to discuss, but it is insist by the other group. Okay, so for learning objective, of course, you have to all know all the gas law. Okay, there are Boyle's law, Charles law, and combined gas law. Boyle's law, Charles law, the other one is between P and T, uh, Gay-Lussac, Gay-Lussac law. Okay, yeah, this one. Okay, and then a combination of all the gas law. All right, so you have to memorize all the formulas. Okay, right. Definitely you have to be careful with the unit. Okay, so read the question carefully. Okay, identify whether the unit is suitable or you need to change the unit. Okay, very important for you not to straight away use a formula without looking at the suitability of the unit. So please do that. Okay. I wish that everybody enter the class before the class start. So if not, then I'll be I have to stop and look at, okay, who's entering the class and so on. Yeah. Right. Remember that the unit is very important. Okay. All right. Okay. So apart from that, of course, gas densities, PV equal to nRT, Dalton's law of partial pressure. Okay. So those are things that you have to memorize, as well as try to do questions, especially calculation, because in gas topic, there's a lot of calculation. Yeah. All right. These are explanations. Involve a lot of explanation. Okay. So that will be gas. Okay. And the second part, we discuss about liquid. Okay. And we discuss about intermolecular attractions, the properties of liquids. Okay. And the most important is we discuss about intermolecular and intramolecular forces. Okay. So you have to know all this. Okay. You have to be able to describe each of these. Okay. Of course, to differentiate intramolecular and intermolecular, you can give, you understand the difference between these intermolecular forces and intramolecular forces, and you are able to give example of compound. For example, you have to give compound, you have to give an example of polar compound or non-polar compound, and why it is polar and why it is non-polar. Okay, so please remember that you should be able to do that. You have to be able to do that. Okay, so what is hydrogen bond? Definition, giving examples. Okay. Van der Waals forces or London forces, induced dipole or ion induced dipole. So this is very important. Okay, right? And this is also that we have discussed. Just a moment, yeah. Okay, you need to know the definition of all this. Okay, what is surface tension? What is wetting? What is evaporation? What is viscosity? So you have to know the definition of all this, right? So what's the meaning of surface tension, wettability? Okay, so right. Evaporation process, sublimation process. Okay, what is sublimation process? So you have to know. Okay, it is in the slide. It is in the lecture notes. Okay, sublimation process. What is the definition? And then you can, if you wish, either is good you draw. Okay, right. So that will be the for liquids. Yeah. Okay, so in updated slide, you have this phase diagram showing the conversion between solid, liquid, and gas. Right. So now is the solid part. So that's why I would like to discuss a bit more on the solid part. Okay. Bonding in metals, I did ask you to read. Yeah. Okay, so make sure when I ask you to read that you have to do that. Okay. But I would like to stress on this. This is bonding in metal. That I have not discussed in detail is the lattice structure or crystal lattice. Yeah. So we start with simple cubic. Okay. Okay, with simple cubic, but I did share some videos on how you can understand the difference between simple cubic, face-centered cubic, and body-centered cubic. Okay, so there are a few things that is very important for you to know, especially for your test 2 for this particular part. Okay, so for all the system, simple cubic, face-centered cubic, and body-centered cubic. Okay, let's look at by one. So this is simple cubic. Okay, so you can see that based on simple cubic, Okay, this is what we call as 1 unit cell. 1 unit cell. Okay, and you can see that every edge at every corner contribute 1/8 atom. So in total, for simple cubic, you have 1 atom per unit cell. Yeah. So this is important information that you have to know. Okay. So for simple cubic, you have 1 atom per unit cell. And why is that? Because each corner will contribute 1/8. Of 8 corners, you get 1 atom. Okay. Now the second structure, lattice structure, face-centered cubic. Okay. So yes, it is 4 atoms, but easier if you look at this one. Okay. How we get 4 atoms? Again, this is the unit cell. Okay. The unit cell for face-centered cubics. So the contribution of atoms comes from 8 corners, 1/8, which contribute to 1 atom, and half of atom at 6 faces. Okay, so 3 atoms, and then in the end you get 4 atoms per unit cell for face-centered cubic. All right. Okay. So the last one for solid crystal structure is body-centered cubic. Okay, so this is what it looks like for body-centered cubic. Okay. So how many atoms for body-centered cubics? 2 atoms. Yeah. So it's quite easy to identify because you have 1/8 times 8. 8 corners will contribute 1 atom. Okay, and you have 1 in the middle. So you have 1/8 times 8 plus 1. So for body-centered cubic, you have 2 atoms per unit cell. Okay, so simple cubic, 1 atom, face-centered cubic, 4 atoms, body-centered cubic, 2 atoms. Yeah, 2 atoms. Okay, you have to know that. That should be understood when you have that structure. Okay, you know that will be the most important information. All right, and the second information that is very important and easier if you memorize it, okay, is the relation between edge length and radius of atom for unit cell. Okay, so you can see this is for simple cubic cell. So simple cubic cell A, whatever, sometimes the question does not give you A, but A means the edge cell, the edge length of the cell. Okay, edge length of the unit cell. Okay, so it can be represented D or represented just edge length. So you must know it doesn't always to be A. Yeah? So in this slide, it is A. So A equal to R. R is the radius of atom. Okay, R is the radius of this particular atom. So this is so R is between here. So simple cubic, this one. Okay, for face-centered cubic, okay, for face-centered cubic, if you wish to prove that, you wish to do the calculation, but this is the formula. The relation between H length and radius is A equal to square root of 8 times R. Okay. And the last one, okay, this is how, okay, this is for, okay, it is not there, but this is for BCC, body centered cubic. Okay, so for body centered cubic, okay, I don't have the final, should be there. So R equal to square root of 4A. Okay, so let's look at exercise. Okay, now this question is very important for you, very important for you. Okay, silver crystal are face-centered cubic. Now you are given face-centered cubic with cell H, okay, length of 4.086 angstrom. I hope that you know the unit angstrom. Okay. Now, what is the atomic radius of silver? Argentum is silver in this crystal. And how many nearest neighbors does each atom have? Okay, means that in a unit cell. And calculate the density of metallic silver. Okay, so you have face-centered cubic. So face-centered cubic is this one. This one is body-centered. Okay. Okay, so the formula, right? So before you start, okay, you don't have to derive actually. You don't have to derive because derive will spend, you need to spend some time to derive. So I suggest that you remember the formula. So two things that you know, face-centered cubic, you have 4 atoms, right? And the formulation is A equal to square root of 8 times R. A equals to square root of 8 times R. You can solve the square root of 8. Okay, so these two informations should be in you before you start to solve this question. So if you look at the answer, okay, now you know these are given to you, the answer. Okay, what is the atomic radius? Okay, so but you are not given the radius, you are given the H cell, the cell H length. Okay, so since you know the relation between cell H length and the radius, so you can calculate the radius directly by using that formula. Okay, so that is for question number 1. So how many nearest neighbor does each atom have? Okay, since you know that FCC has 4 atoms, so directly you know the answer is 4. Okay, the 4 atoms. Okay. Okay. Now is calculate the density of metallic silver. Okay, again, this is something that you should know from your previous knowledge. Density, which is D equal to mass over volume, right? This is quite common. So you have to find the mass of 4 atoms. Okay, mass of 4 atoms. And then you have to also know the volume. Okay, right. So what you can do, okay, first solve the volume. So you know that from this picture, okay, volume is A with the power of 3, yeah, cube, yeah. So you know the H cell, right? You know the value of A, so you just calculate, okay? So this one. So this is just a conversion of units. Okay, so this is the original one. You just have to power of 3. Okay, so you should know Armstrong is 10 to minus 10 meter, right? You have to know that. Okay, units. Right, so volume is equal to A with the power of 3. So now the next question, the next one that we need to calculate is mass of 4 atoms. Okay, so now it is given to you. Okay, so mass means that 4 atoms times mass number of silver, right? You have to do this, okay? And you have to divide with Avogadro number. Why? Because this mass number is for 1 mole. Okay, this is for 1 mole of silver. Okay, but we are talking about 4 atoms only. That's why you have to divide with Avogadro number. So you can see here 4 atoms times this is the mass number, the molecular weight for the atomic weight for silver, and then divide by Avogadro number. So now you get the mass for 4 atoms in gram. So this is the final to get the density is mass divide with volume. So you get the density. Okay. So that's why those two informations are very important. Okay. How many numbers of atoms per unit cell? Okay. And the relation between each cell and radius. Okay, so the question will be, you might be given radius, you might be given something else, density. So you have to know how to manipulate the information given. Okay, questions for this topic? Yes? Question for this topic? You okay?
Doctor,
Yes?
for slide 76,
Mm-hmm.
for the question 1, is it necessary for us to change to another unit or can just use the Armstrong?
But you have to use the right unit finally, because usually unit for density is gram per, okay? So you can use gram per angstrom, but it's not normal. But since the question is not asking you to convert, then it's fine with me. Yeah? But if the question asks, then you have to convert. But remember, you have to put the units by the end. If you don't want to change it, change the Armstrong into centimeter cube or so. Okay? Okay? You all right? Okay, any
Okay,
other
thank you,
question?
Doctor.
Okay, any other question on this topic before we move to bonding topic? Okay, somebody asked in chat. I don't know whether. Nothing. Okay, good. So now we change to revise back a bit on bonding, okay? Bonding part 1. Okay, I share it here. Just a moment, right? I'll try to find the bonding topic, okay? Okay, so this one is to share with you, just to highlight what are the most important thing, especially for your test 2. Okay, so very important to, of course, know about Lewis structure. Okay, Lewis structure, very important. Remember that, you must know about Lewis structure and how ionic bond is formed. Okay, so I didn't discuss on how to draw Lewis structure for ionic bond. Most of the time we draw Lewis structure for covalent compound. Yeah, remember that we discussed about covalent compound, but you must know how to draw Lewis structure for ionic compound. I repeat that you must know how to draw Lewis structure for ionic compound. So please check back, okay? So this is learning objective for part 1. Yeah. So part 1, of course, you have to know different types of bonding. Bond-Haber cycle is not important, okay? So you don't have to uh, 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 really worry about this, okay? But you have to be well versed about Lewis structure and how to draw or how to explain ionic bond and draw Lewis structure for ionic compound. Okay, right. So this is for part 1. Yeah, polarity is very important as well. Okay, okay, electronegativity is very important. Okay, so for you to decide, okay, whether the compound will form, whether the compound, or when you have two elements, and they have different electronegativity value, so how do you decide whether they will form ionic bond or they will form covalent bond? Is the difference of the dipole moment. Yeah, the difference in dipole moment, or difference of dipole moment is actually the difference between electronegativity value between the elements. For example, this one. So 1.83 is actually the difference of electronegativity due to the difference of electronegativity between H and F. Okay, so you have to know the Pauling scale. Remember that electronegativity, the value is given in a form of scale. It's not an energy, it's not, but it is given a Pauling scale. So if the value of difference, electronegativity, is 2 and above, then they will form ionic bond. If it is Below 2, they will form covalent bond. Okay, I hope that you get that. So the difference in electronegativity, should be 2 and above, so that the ionic form will bond. But below than that, it should be covalent bond. Okay. Okay. So Lewis structure is very important. You have to know that. All right. So now let's go to the next part 2. Okay. So for part 2, okay, so we discussed about Vesper, right? So Vesper, and you have to define what is Vesper, and you have to know about this table, okay? And then you have to know about this table. You have to know when you have 4 bonding domain, 0 non-bonding domain, what is the geometrical, what is the molecular shape. So you have to know all this, okay? And you have to know how to properly draw the specific molecular structure, okay? Right? So Vesper is important, especially for your test 2 at this moment, okay? And then the rest are just, of course, this one, valence bond theory, molecular orbital theory, okay? So let me just highlight Vesper, Lewis structure, so ionic bond, okay? So very important. Okay, any question on this?
Doctor, to confirm, we will just, for this part, we will refer to the calculation, right? Or we also have to deal with the terms?
All of it. Calculation means, I don't know, which calculation are you referring to?
I mean, the Vesper, Visip,
Vesper,
VSEP.
okay?
Yeah.
There is no calculation, but what involved is you have to know how many non-bonding, how many bonding domain, and from there you can conclude whether you have what kind of molecular structure. Remember, you have 2 types, electronic geometry as well as molecular geometry. So electronic geometry is the general one. Molecular geometry is a specific one, okay? So I refer back to the table. Okay, for example, if you are given NH3, yeah? Let's say the question asks NH3, and you have to identify one is the electronic geometry, the other one is the molecular geometry, okay? So you have to look at the question. If they don't ask, they just ask molecular structure, then you go straight to the molecular geometry. So if you are given NH3, okay, you have to know how many bonding domain and how many non-bonding domain. Okay, and how do you know that? We have discussed, okay, steps in using Vesper. You have to draw Lewis structure. That's why Lewis structure is very important. Okay, but Lewis structure is 2D. Yeah, it is not 3D. But when it comes to Vesper, we are talking about molecular geometry, which is now in 3D form. Yeah. Okay, so back to the one that I've given the example of NH3. So from the Lewis structure, you have identified there are 3 bonding domains and 1 non-bonding domain. Okay, so we can conclude that it has electronic geometry of tetrahedral, but molecular geometry of trigonal pyramidal. Yeah, so you must remember there is a difference between electronic geometry and molecular geometry. So there is no calculation involved. Okay, but you have to, if you are asked to draw, then you have to draw properly, showing the lone pair and the position of the bond. Okay, I'm not asking you to measure the angle, but it must be, let's, for example, if you have to draw tetrahedral, that it must look like tetrahedral. Okay, so if it is just Lewis structure, usually we can just like this one. Okay, this is 2D. Okay, but when you have in Vesper molecular structure, you have to show the 3D form. Okay, means that you have to show there is a difference in terms of angle, right? Okay, questions? But of course, your question about whether you need to to define, to explain what is Vesper. If the question asks, of course, you have to answer that. So what is Vesper? What is the principle of Vesper? I think we have discussed that during our lecture. Okay, questions?
Doctor, one last question regarding the format of exam. Like, we're gonna choose again 3 questions, or
No, you have to answer all questions. For this time, you have to answer all questions.
so there will be 4 questions, Doctor.
Basically, you don't worry about that. But under bonding, there are, I think, 2 or 3. And under solid, gas, and liquid, the same numbers. And with the ABs and all.
Okay, Doctor, thank you.
All right. Okay, so I think that's it. Okay, so what is important for you to download the updated slide on solid, liquid, and gas if you haven't done that. Okay, everything is in Putra Blast. Please do that as soon as possible. Sometimes the Putra Blast is not very stable. You know that. Okay. Yes, 1 hour is provided, just like your test one. Okay, so the other one that is very important for you, if you haven't looked at the tutorial question yet, please do that. Please do that. And I have given the suggested answer for those bonding topic as well as solid, liquid, and gas topic. Okay, so I think you are well equipped now to do the test, because next Monday will be a public holiday, so there will be no class. So your class will be on, your test will be on Wednesday. So as usual, I will start to alert you 15 minutes before the test. And if Putra Blast is doing fine, then you can access the question and submit the answer in Putra Blast system. It's just that I'm not very satisfied with some of the PDF file that some of you sent to me during your first test. So please do check your apps or whatever that you have. so that you can have a good PDF file. Some seems to be very dark. Some does not give me, you didn't write your matrix number properly. So please comply to the instruction. Okay, if there is no questions, then I think good luck, yeah, for your test one next week. And tomorrow, I'm not sure whether the demonstrator has told you that it is not the one that I shared. I thought it's the one because they shared with me the video. It is supposed to be heat of reaction, but I don't know whether the video is completed or not yet. So please refer to Fatima for the session tomorrow. I will not be able to join tomorrow because I have an urgent meeting at 3 o'clock. Yeah. All right. So thank you so much, and please do study, especially, yeah, I think it's quite easy if you study, and if you look at the tutorial, I think you should get a good marks.
Thank you, Doctor.
All right, bye-bye.
Thank you, Doctor.
Doctor.
Thank you, Doctor.